Recall that we define the order of a differential equation as the highest derivative that arises in the differential equation. Consider the spring mass application that can model the position u of t of a mass on a spring by the second order differential equation m times u double prime plus gamma times u prime plus k times u equals the forcing function f of t. Notice here that we call it a second order differential equation because the highest derivative involved is the second derivative of u. Now we can rewrite this second order differential equation as a system of differential equations if we consider both the position u of t and the velocity v of t, which is u prime. With this, we have that u double prime of t is v prime of t, and we can rewrite our second order differential equation as m times v prime of t plus gamma times v of t plus k times u equals g of t by replacing u prime with v and u double prime with v prime. Now we have a first order differential equation because the highest order of the derivative is the first derivative of v. Additionally, we can solve this for v prime by subtracting gamma times v of t and k times u from both sides and dividing by m. Doing this, we get v prime of t is negative gamma over m times v of t minus k over m times u of t plus 1 over m times g of t. And this equation, together with the simpler differential equation u prime of t equals v of t, gives a system of differential equations. The system is made up of the two derivatives u prime of t equals v of t and v prime of t equals negative gamma over m times v of t minus k over m times u of t plus g of t. So here, we replace the first derivative u prime of t with the velocity v of t and changed our second order differential equation into a two-dimensional system of differential equations. And in general, we can change an order n differential equation given by the nth derivative of y equals some function of t, y, y prime, all the way up to the n minus first derivative of y, into an n-dimensional system of differential equations by making the change x1 equals y, x2 equals y prime, down the line to xn equals the n minus first derivative of y. This gives the system x1 prime equals x2, since x2 is y prime and x1 is y, x2 prime equals x3, down the line to xn minus 1 prime equals xn, and finally xn prime is the nth derivative of y, which was given by the original differential equation f of t x1, x2 up to xn. So as we study how to solve systems of differential equations, we also give ourselves another method to solve higher order single differential equations.